appearing on the screen sharing? Or is it just clear? Clear, okay, right. Let me have a look. How many of you are online? Oh, half of the class, only half of the class are online. So I'll just wait. I'll give them a few minutes. Just tell me if any boxes start to block the screen sharing, okay? Later, because right now I think it's clear. Regardless of whether the whole class is online, by 11:05 I'll be starting, or otherwise we'll just, oh, no, there's a box appearing now. 2 boxes. Yeah, just change it. I'll just change the setting now. Okay, it's now 11:05. Assalamualaikum and very good morning, everyone. Before I start my lecture, I'd like to make a few announcements. Okay, both are on the your practical class. Yes, Ruyin, you raise your hand. Do you have anything to ask me? Okay, I shall continue. I have two announcements regarding the practical class. Okay, so Group A will be having the practical class tomorrow, and Group B will be having it same time next week on Tuesday. Last week, a couple of your classmates came to see me and asked whether we can reschedule the ones for Group B. Okay, but I have actually discussed the matter with our science officer, Mr. Hafiz, as well as the assistant science officers. And they say that no, they're not free on other days. So we shall be having the one, they're not free other days next week. Okay, and secondly, we won't be able to like combine the two groups together this week because we don't have enough resources to actually use both of the labs for the whole of the class. 115 of you, 115 of you. Okay, so we shall be following the schedule. Okay, as has been arranged from the beginning of the semester, which is Group A will be having the practical this week, tomorrow at 2 o'clock, and Group B will be having the practical class same time next week on Tuesday. Okay? Okay, that's the first announcement for the practical class. Second announcement for the same practical class is for your lab report. Okay, it shall be there are two parts to it. Okay, one is not really lab assessment. The first part will be the individual assessment, whereby you will have to sit for a short quiz, okay, after the practical class, and there'll be a deadline. Remember, there will always be a deadline for the assessment. Okay, for this practical this week and next week, the deadline will be this Friday. Okay, remember that. So that will be the individual assessment. Similarly, for the other assessment, which will be the group one, okay, please follow my instructions, which I shall be sharing with you at the end later today. Okay, later in the day, I'll be sharing with you the template of the lab report. Okay, so please take note that group leaders or one of the group members are supposed to print out the template, bring it together to your class. Okay, and so during the class, please follow the instructions, whatever you have to do. Okay, and after you finish all the assigned tasks, after you complete all your assigned tasks, please scan your lab report and upload it onto eLearn. Okay, which is specific. The page will be specific. Is it on this hold on, let me have a look at the schedule. Okay. Sorry, not next week. It's on the 4th of July, which is still your teaching week. Okay, which is still a teaching week. So that's why it has been scheduled as such. Next week, we won't be having any practical. Okay, I know that you think that you want to go for the revision week, but somehow you still need to follow the schedule because of the it is still a teaching week. Okay, so remember, later today I'll be sharing you the template for the practical class, for the practical report, and one of your group mates, please So each group needs to bring their own template to the class and complete all the tasks, scan it, and post it online on eLearn. Okay, so let's start the lecture. I'll be recording the lecture so that since there are only 93 of you, that means around 20 are still missing. So I suppose I will share the recording later. So I'll start the recording now. Okay, Assalamualaikum, a very good morning, everyone. Again, this is the first part of the lecture 1 for the female reproductive system. Okay, we're done with the male reproductive system. So we're now moving on to the last part or the last series of lectures on the reproductive system physiology, which is the female reproductive system. And there'll be 3 hours. The series of lectures will involve 3 hours. Okay, and this is the first hour. At 12 o'clock, there'll be the second hour of the lecture. So what you'll be learning from this topic are, firstly, I'm going to show you the functional anatomy of the female reproductive organs, because from that you will better understand the cycles that are involved, okay, both the uterine cycles as well as the menstrual cycle itself, okay, and then discuss the functions of the female reproductive organs. Okay, and then I'll move on to have a look at the functions of the female sex hormones and also the hormonal control of ovarian functions, because the ovaries are the um, gonads of the female, and they are the ones that produce the female sexual hormones. Okay, and then after we finish discussing about the cycles, we then go on to discuss the pregnancy stage and the hormonal and as well as other changes associated with pregnancy. Okay. After that, at the end of the series of lectures, towards the end of the series of lectures, we're going to be discussing the neuroendocrine control of parturition, which is delivery of the fetus, okay, of the baby. Then we are going to revisit the control of milk production as well as milk ejection, which we have actually um, discussed earlier on in the semester. Okay. So now let's take a look at the functional anatomy of the female reproductive organs. Oh, sorry, forgot about this. Okay, this is how the lectures will be progressing. Okay, these different subtopics. Okay. So before going on to the functional anatomy of the female reproductive system, let's take a look at the general introduction to the female reproductive system. Okay, remember previously we talked about sperm production. Okay, upon reaching puberty, the male will start to produce sperm. Okay, and somehow sperm production is a continuous process beginning from puberty until the man or the male reaches his death. Okay, so it's a continuous process. Doesn't matter how old the man is, he will keep on producing sperm. Okay, as long as the gonad is normal and is present. Okay, but in comparison to the male, in the female, gamete production is not continuous. Okay, it's a cyclical process, and this maturation and release of the ovum, okay, is known as the ovulation process. It starts to occur after puberty, which is known as menarche, and stops at menopause. Okay, why this is so, we shall be looking at it after this. So basically, there are two main phases for the female reproductive function. One, the first phase is preparation for conception and pregnancy. This is what this is what is meant by the cyclical maturation and release of ovum. That means in every cycle there'll be one egg. Well, majority of the time it's only one egg. Only one egg will reach the most mature stage, and it'll be released at ovulation. Okay, so if this ovum is fertilized, then it will develop, and then it will develop into a fetus, and it will be implanted into the uterus of the female. And there are different changes that occur during pregnancy. Okay, so what is meant by menstrual cycles? Menstrual cycles is actually a combination between ovarian cycles and the endometrial cycles, okay, or the uterine cycles. So what is ovarian cycles? It's actually the changes in secretion of hormones by the ovaries. Okay, that means throughout the month, or generally it occurs in a 28-day period, there'll be different changes in the hormonal secretion. Okay, and in relation to the changes in the hormonal secretion, there will be endometrial changes, which means that there will also be changes in the uterine endometrial wall. Okay, this is to prepare the body, the female body, in case fertilization occurs. So the uterus should be ready for implantation, right? So basically, since it's a combination between ovarian and endometrial cycles, there is interactions between the ovaries, hypothalamus, and the anterior pituitary. Okay. Why? Because we have the GnRH coming from the hypothalamus. Okay. And this is released into the circulation, and upon reaching the anterior pituitary, it will induce the secretion of the luteinizing hormone as well as the follicular stimulating hormone. Okay. LH and FSH respectively. And the length varies in each and every individual, in each and every female, but on average, the cycle lasts for about 28 days. Okay, why there are variation between one person to another, we will take a look at it later today. Okay, day one of the cycle is the first day of the menstrual flow, which is known as menstruation. Okay, and at the middle of each cycle, one oocyte will mature in the ovaries, and it then gets ovulated, which means that it gets released from the ovary and captured by the ephemerae of the uterine tube, and then travels into the uterus. But along the way, for it to be fertilized, the sperm must reach the egg within the area of the fallopian tube. Okay, because of the because of the short viability of the egg. So as I said earlier, the uterus prepares itself to receive and nourish a fertilized egg. That is why there is also an endometrial cycle. Okay, because when there is a need for it to receive implantation, okay, it prepares itself with the thickening of the wall. So what happens if there is no pregnancy? That means the egg is released, but it is not fertilized by the sperm. Menstruation then occurs. Okay, because with no fertilization, the cycle keeps on continuing and then leading to menstruation. Okay, so this is the summary, but let's move into more detail. So we know that the ovary is a very active endocrine organ. Okay? So it produces egg or oocyte, which is the female gamete. It also has, it also goes through, they also go through cyclical changes, which it involves hormonal secretion, okay, as well as cyclical changes in the uterus. So once the egg is released, if a sperm enters the female reproductive tract, fertilization can occur, okay, leading to implantation as well as pregnancy. Okay, and at the end of the pregnancy, there'll be the parturition process, and this leads on to the lactation process. Okay. So let's take a look at the functional anatomy of the female reproductive system. It includes the internal genitalia as well as the external genitalia. So let's take a look at the internal genitalia. This is a cross section from the side through the pelvis. Okay, so there is the presence of the ovary there. Okay, of course we can only see one ovary at the moment. There's also the uterine tube or the fallopian tube, okay, which extends from the its connection from the ovary to the uterus. Okay, and there is the uterus there, the cervix, which is the opening of the uterus, and the vagina. As you can see here, in comparison to the male reproductive tract, the urethra and the vagina has two different are not connected. Okay, so they have different openings from the urinary bladder to the urethra. Okay, one opening. From the uterus, okay, through the cervix is one opening by the vagina. Okay, looking at the cross section from the front, there is a continuity of the ductal system, as we can see here. So there are a pair of ovaries, one on the right and one on the left. There are also a pair of the uterine or fallopian tubes, okay, having fimbriae at the end of the fallopian tube, which actually are the ones important for the transport of the ovum into the fallopian tube. Okay, so one on the right and one on the left. And we see here there's this uterus. Okay, so they are all interconnected. Okay, and then opening of the uterus, which is the cervix, and this is connected to the vagina, right? So how about the external genitalia, the vulva? We have here is the mons pubis, okay, the front of the vagina. There's also the labia majora. Okay, so the labia majora looks like two sacs, and they are actually the homologue to the scrotum in the male. There is also the labia minora, okay, in there. The clitoris, which is at the front of the labia minora. Okay, so the clitoris is actually the homologue to the penis. So that means it can, it is receptive to stimulation as well. Okay, there's a vestibule, which is all these components here, and the vaginal opening. Okay, this is where the opening is where the sperm enters, as well as the route for delivery of the baby. Okay, so we have the ovarian function being oogenesis or gametogenesis of the female gamete. Okay, female gamete being either you can either call it the egg or the ovum. Okay, and then the egg goes through maturation, and at one stage, at the middle of the cycle, there will be expulsion of the mature oocyte. So this process is known as ovulation. Okay, the ovary also secretes hormones, three important hormones, which are the steroid sex hormones, estrogen, as well as progesterone. And it also secretes the peptide hormone inhibin. Okay, later on we'll see that there are two types of inhibin. One is the inhibin A and the other is inhibin B. It's not really important because their functions are the same. Okay, to inhibit FSH and LH, well, to inhibit FSH actually, but because of the nature in the menstrual cycle, at different stages, it is secreted by different types of cells. Okay, that's why in the beginning it is inhibin A and at the end is inhibin B, because both inhibin A and B are secreted by different cells. Okay, so the ovarian follicle is developed through, is developed through the process of gametogenesis, and it has endocrine function. That means it is important in secretion, in human hormone secretion. Later on in the cycle, once ovulation occurs, the follicle will be empty and it loses its endocrine function. Okay, but in the beginning, it still has the endocrine function, which is a corpus luteum. Okay, towards the end, it will lose its endocrine function and it is known as the corpus albicans. So, in comparison to the male, egg development does not occur at puberty, but production of eggs begins during the fetal stage. Okay, which means that at birth, okay, and during fetal stage, the eggs have been developed in the female fetus. So by the time the fetus is delivered, there will be between 2 to 4 million of eggs present within its ovaries. Okay, but along the way, most of these gametes, most of these ovum will go through degeneration or atresia. Okay, so basically no new eggs appear after birth, or similarly no new eggs appear after puberty. Okay, so a newborn female already has all the germ cells she will ever have. But at puberty, as I said, most of them from the beginning at birth, 2 to 4 million of eggs, most of them will go through atresia. So at puberty, only about 400,000 eggs will remain. And out of the 400,000 eggs, only about between 400 to 450 eggs will go through ovulation throughout a woman's lifetime. Okay. And we also have to remember that there is also the aging effects on the egg. Eggs ovulated near the age of 50 are 35 to 40 years older than those ovulated just after puberty. And because of this reason, certain congenital defects are more common in offsprings of older women. Okay, such as syndrome, Down syndrome. Okay, this is one of the reason. This is due to the most of the time is due to the old age of the egg. So let's take a look at the oogenesis process. We have the spermatogonia. Sorry, oogonia. What was I thinking? Oogonia. Okay, that goes through mitosis and differentiation. Basically, all oogonia develop into primary oocytes during fetal life. Okay, primary oocyte, as you can see here, is a diploid and therefore it has 46 chromosomes contained within the nucleus. It goes through the first meiotic division in fetal life, okay, and then it goes through meiotic arrest. Okay, see here. Firstly, oogonia goes through mitosis, which means it starts. There is a creation of a clone of cells, and then it starts to go through the first meiotic division, but then stops halfway. Okay, that means primary oocyte can be found in a female fetus, okay, or female baby. But upon reaching puberty, the first meiotic division finishes, okay, and what is are developed are a secondary oocyte, okay, as well as a first polar body, okay. And going through the second meiotic division, which is completed after fertilization, which we shall be looking at after this, okay, there is the creation of the ovum and a second polar body. So the polar bodies will be phagocytosed by the body, okay. So the secondary oocyte and the ovum both are haploid. Okay. But of course, the ovum only has one chromatid per chromosome in preparation for fertilization. Okay. Now let's take a look at the follicular growth. Each and every one of the egg exists in follicles, okay, which is the one that protects the eggs in the ovary. So it begins as a primordial follicle, which means that it's very, very basic. It only has the egg and one layer of granulosa cells. I'm sorry. But at puberty, the anterior pituitary starts to release FSH and LH. Okay, and these act upon the ovary and the follicles, which means that the follicle starts to grow. So basically, the primordial follicle then is stimulated to become the primary follicle. The egg increases its size, and there's also the increment of granulosa cells. So that means more and more granulosa cells starts to develop, and also the creation of the protective layer known as the zona pellucida. Okay, you can see that's the protective layer there. It then goes on to develop into preantral follicle. This begins to develop at the beginning of each menstrual cycle. Okay, and theca cells are formed. You can see here, theca cells are formed. And granulosa cells start to secrete estrogen, progesterone, as well as inhibin. So in the early antral follicle, the antrum, which is the fluid-filled space, starts to form. Out of those, in each and every one of the cycle, about 10 to 25 follicles will be stimulated to grow. Okay, but at the middle of the follicular phase, sorry, only one dominant follicle will be selected, and the remaining follicles will go through atresia. Okay, so if you think about it, in every cycle in the female, only one egg will be released. Okay, sometimes, very, very seldom, 2 eggs may be produced and released at ovulation. And these eggs, if both of them are fertilized, will create paternal twins, okay, or non-identical twins, all right, because they are genetically, they are similar to normal siblings, okay? Even though they are born at the same time, they are genetically, they are similar to siblings. So what is the mature follicle? It's very big. It's about 1 to 1.5 centimeter is the size. What contains within it is the secondary oocyte and cumulus ovorus. Okay, that's it. Okay, that's the cumulus ovorus, which is the one that protects the egg, the secondary oocyte, and actually joins the egg to the follicle. Okay, and during ovulation, what happens is the egg will be released together with the zona pellucida, granulosa cells, and the cumulus ovorus. Okay. Okay, let's take a look at the video which actually talks about the maturation of the follicle and the oocyte, which is a process, and it's a little easier for you to see in the video.
A primordial follicle consists of an oocyte surrounded by a single layer of squamous granulosa cells. A primordial follicle becomes a primary follicle as the granulosa cells become enlarged and cuboidal. The primary follicle enlarges, and the granulosa cells form more than one layer. the zona pellucida forms around the oocyte. The structure is called a secondary follicle when fluid-filled vesicles develop among the granulosa cells and a well-developed capsule, or theca, becomes apparent around the granulosa cells. The theca possesses internal and external layers. The structure is called a mature follicle when the fluid-filled vesicles form a single antrum. At full maturity, the oocyte is located in the cumulus mass. During ovulation, the oocyte is released from the follicle, along with some surrounding granulosa cells of the cumulus mass, called the corona radiata. Following ovulation, the granulosa cells divide rapidly and enlarge to form the yellow corpus luteum. When the corpus luteum degenerates, it forms the white corpus albicans.
Okay, as I said earlier, the corpus luteum has endocrine function, but corpus albicans does not. Okay, so we shall have a look what happens in the cycle. Why is this significant in the cycle? I shall take a short break here, so I shall stop the recording, and we'll be starting in a 1 minute time. I need a break actually. Okay.